Greetings from Teacher Richard, boys and girls. We are back on our science lesson. The last time we were here, we were looking at lenses. Remember, basically optical instruments. And when we talked about optical instruments, I remember we told you these are instruments that work only when there is presence of light. Today, we are having another optical instrument, but this time it doesn't use a lens, okay? Doesn't use a lens, but we use it in the formation of images, okay? I'm just going to show you briefly how these devices, all these objects look like, okay? One of them is here, okay? One of them is here. It's a box painted black, both inside and outside. We don't mind much if outside is not black, but inside it must be black, okay? We're going to know the reason why so. This box, it must have a screen on one end. It must have a tiny hole. That tiny hole, we have made it out of a pin, okay? So you can use even a pair of compass to pierce that hole. So it is a box with a pinhole on one side and, okay, a waxed paper, which we normally call in classes when we are learning tracing paper, okay, on the other end, okay? So this device or this object is what we're going to learn about. And somebody can guess what it is, okay? If somebody can guess what it is, I'll be happy. Is there any child who can guess what this is? Okay? Let me learn. What do you think it is? If I can, it has a pinhole. It has, okay, this screen made of waxed paper. Check my action, and I think you can guess what it is. Check my action. What could this be? Yes, this is a pinhole camera. It's what we're going to look at, okay? It's a pinhole camera. I can make it out of this box, or I can make it out of a tube like this. Both work, okay? In the due course of our lesson, somebody is going to use them and we shall see whether they really work, okay? Yeah. There is one thing missing on this. This one is not going to work, but this one works clearly. I will explain why this one does not work at the moment and this one works later in the course of our lesson. So basically, you need to know that this is what we're going to learn. It is a pinhole camera. Thank you very much. Okay, as we have already said, we said that we're looking at a pinhole camera. I remember telling you that it is just, it can be a box, can be a tube, because I was showing you two, okay? It's a camera made up of a box with a pinhole on one end and a waxed paper, which I said we call tracing paper on the other end. Somebody can use a tube, you can use a box, but it should have, okay, a pinhole on one end and a waxed paper, which we normally call in our classes tracing papers. You remember the papers in mathematics used to make when you apply oil? You used to apply oil or Vaseline on it so that it can trace work. That is the paper I'm talking about, okay? The waxed paper. So when you make an object using all that I'm mentioning, you are making what we call a pinhole camera. A pinhole camera uses those things. A box, it must be painted black inside. If it's not painted black inside, there will be a lot of reflection of light. The image you want to see of an object will not be formed, and that image is formed on the waxed paper. Now when the image is being formed, that's how it is supposed to be. Now I want you to see features here, okay? This box, look at this box. That's the box I was showing you. Then this hole is the pinhole, okay, that I was showing you. Now, on the other end, you remember on the box, there was a waxed paper. That is the side where the waxed paper is, okay? I want you to check that red light. I'm moving, okay? Follow it as I do my work, okay? This is going to be the image of this object. You see this object, okay? So now, this is how a pinhole camera does its work. Now, if you place an object and you look at that object, you pass your eye through here, you see through this hole, what is going to happen is the object which is here, okay, this object, when you look at it through this hole, it appears like this, okay? The object appears upside down, all right? Now, we need to know why this object here will appear upside what? Down, okay? So, look at here. Check that light ray. Remember, light travels in what? A straight what? A straight line. Thank you. Thank you for completing that. Light travels in a straight line. Check here. Look at this. Light ray passing here. Look at this one. It is passing through this pinhole, but in a straight line. Now, this is how this pinhole camera forms an image that is upside down. That's inverted. We are saying it forms an inverted, upside down image because light travels in a straight line. But we are not going to end there, okay? Because still you are going to ask me, if light passes through a straight line, how does this light passing through a straight line turn this image upside down? I want you to be very attentive. Now listen carefully and we see how it does it, okay? Check the light rays from the top of this object. Our object is this arrow here. This object which looks like an arrow here. Are you seeing it? Yes. Now I want somebody to look at this. Light rays passing from the top of this object. Are you seeing? The light rays, they come with the image, okay? This image, they are going to, see here. It is passing with this image. You see, light ray from the top of this object traveling here. That's why we say it travels in a straight line. You see here? Passing with the image, and it casts that image here. The top part appears here, okay? Then come to the bottom. Come to the bottom of the object. The light rays from the bottom here, when they are traveling to pass through this pinhole, they will travel straight. From bottom, the light rays will appear on top there on the screen. Our screen is made out of what? We said out of a waxed paper. In class, when you are doing mathematics, those graph work, you normally call it a tracing what? Tracing paper. It's the one I'm calling waxed paper here, okay? So we say this image appears upside down because light rays traveling from the top of the object, see it here. Light rays traveling from the top of the object. Check here. The light rays traveling from the top of the object. They strike. We can say strike. You can use the word hit, H-I-T. You can use the word strike, okay? The light rays traveling from the top of this object strike the screen. This is our screen. This is where our waxed paper is. Strike the screen. I'm using that wax paper as a screen, okay? Where image is formed. Strike the screen. That is the waxed paper from the bottom. Check. Here it is on the top, but here it is striking, okay, the screen from the bottom. Are you seeing that? Check. Follow me. This is the top part of this object. But when the light ray is traveling, see here, it is meeting this screen from the bottom. Are you seeing that? Let's follow this. This is the bottom part of this object. Let's see. The light ray from here is traveling. Where is it going to hit or strike the screen? It is from the top. Now, if you see these things happening, here the top part appears from the bottom. Then the bottom part here appears from the top. How will that image look like? Will it still be upright or it will be upside down? When you look at that, it automatically changes that image upside down. So when they ask you why the image formed by a pinhole camera appears upside down, for you, you are free to say it's because light travels in a straight line. Then for that child, okay, who can go an extra mile, okay, you say because light rays travel in a straight line where light from the top of the object, okay, strike or hit the screen from the bottom, while light rays traveling from the bottom of the object hit the screen from the top, turning the image upside down. Okay, are we together? Can somebody try to say that? If I ask you, why does the image formed by a pinhole camera appear upside down? Remember this, I'm going to ask the same question when we're learning the eye, images formed in the eye, even a lens camera, that one for photographs, okay? The same question I'm going to ask. If you do not get this one here, then you are not going to answer me correctly in the other one. So I want to ask you again, why does this image here appear upside down, my children? Can somebody try to guess that? Yes. Follow the light rays here. Begin forming the sentence using this. You follow these light rays. Why? Why does it appear upside down? Check here. This one, this part bottom here is appearing there with this light ray. This one is appearing here with this light ray. It turns the image upside down. Now frame for me that answer. I hear you. Yes, correct. We say it's because light travels in a straight line where the light rays traveling from the top of the object hit or strike the screen from the bottom, while light rays traveling from the bottom of the object strike, or you can use the word hit, okay, the screen from the top, turning the image upside down. Thank you. Can you clap yourself for that? Yes, that's great. Now let's look at this. They can ask you characteristics of images formed on a pinhole camera. I don't want us to just talk about these characteristics. Let's go back. Let's go back here. Let's look at the characteristics. Check the image. This is the image of the object here. I want you to see the size of this object and see the size of that image. Are they the same? What can you say about this? Look at this. Look at this. And look at this. Talk about the size of the two. This is the image. This is the object. This is the image. What can you say about their size? Are they the same? Yes, somebody over there. Correct. I can see the object is bigger than the image, which means for this, since they are asking for the characteristics of the images formed, we shall talk about the image, not the object. We shall say the image. We begin our sentence with the image. The image is smaller than the what? The object. Are we together? Yes, if you are seeing this. Then let us look at the object and the image in their appearance. I can see the object is upright here, okay? It is upright. What about the image? What can you say about it? What can you say about it? Look here. This is upright. The arrow is facing upwards. This way. The arrow is facing where? Somebody there? Correct. It's facing downward. Meaning the whole thing, the object here in its image has turned what? Upside down. Now, which one word can we use to say upside down? Remember that? Can somebody guess and recall it? Yes, it's inverted. The image is inverted. Those are two characteristics of images formed on a pinhole camera. Which other one? Look at this. Remember we said, what is this? Our wax paper works as what? A screen. Okay? Yes? Images that are formed on a screen, last time we said they are real images. So we said the image is real. Okay? So those are the three characteristics of images formed on a pinhole camera. I want you to use the three words: inverted, real, upside down. Are we together? Repeat that. Inverted, real, upside down. Now once you get those three words, form sentences, then they become characteristics. So we said the image is real, the image is upside down, or it is inverted. The image, it is real, upside down. It is smaller than the object. Thank you. That is about characteristics of images formed on a pinhole camera. We don't need to look at that. We have already finished that. Are we together? Okay? Only this new word somebody have put for you here. Diminished. You take that? Diminished. Smaller. Another word for diminished is smaller. Okay? If you do not want to say smaller than the object, you know there are some friends of mine who do not want to write one word like that. They can use this down. Okay? You can use this. Smaller than the object, or you can say diminished. If you cannot write this word, continue with this that you can write. Are we together? Okay. let's look at why the image is inverted. That one, can you now say it? Why do you think the image formed on a pinhole camera is inverted? Why does it appear upside down? I asked that question at first when we were looking at it. Can you say it now? It is now there. The image is inverted because light travels in a straight line. We said where light rays traveling from the top part of the object strike the screen from where? From the bottom. While those rays of light traveling from the bottom of the object strike the screen from the where? From the top. That makes the image to be turned upside down. Okay? So that we finished it. Are we together? Now, they're asking on which principle does a pinhole camera work? Now we're looking at the principles of light traveling in what? A straight line. You saw how those light rays were traveling when they were forming that image upside down. They were traveling in a straight line. So those who are very attentive, we don't need to talk much there. I'm sure you are smiling there. Everything's flowing, okay? Yes. Now let's look at this. Now let's be critical enough on this. There are two things. What determines the size of an image formed in a pinhole camera? Okay? Then what makes the image to appear clear or not clear? Now be very attentive there. That is now an issue. They are asking what determines the size, whether the image appears big or small. This one, I don't want to first rush to that point. Now I want you to look at, if you are viewing or looking at somebody who is about 500 meters away from you, how does that person appear? If the person comes closer to you, how does he appear? Do you think that person's size will be the same? Okay? Look at only that. Somebody is very far from you, you are seeing him, but does he appear when he is bigger? What about when he comes very close to you? Does he appear bigger or smaller? I want you to tell me that. Somebody explain to me. How does that person appear when you are very far from him? Let's say 500 meters, but you are seeing him. Or 200 meters. How does he appear? Correct. When the person is very far and you are seeing him, he appears smaller than his real size. Then when he comes closer to you, you see him as the exact size appears. And that is the same thing we're going to deal with here. Okay? When the image is closer, okay? When the image is closer, you are going to see it appearing, okay, bigger. When you move far, it must reduce its size, okay? It will appear bigger when you're closer, okay? Bigger. Now when you move far, of course, it must begin doing what? Reducing in size. Time may come when you go further, you may not see anything, okay? You may not see anything. Then the second thing is, okay? The second thing, what makes the image to appear clear? Or what will make the image to appear blurred? When I said blurred, B-L-U-R-R-E-D. That's the blurred I'm talking about. Blurred, meaning the image is not clear. If you're using a pinhole camera, what will make the image not to appear clear? Or what will make it appear clear? That will be the size of the pinhole. Okay? Now, if the pinhole is very small as it is supposed to be, the image will appear clear because you have limited the amount of light entering that box, which we call pinhole camera. But when you enlarge, when you make the pinhole bigger, a lot of light will enter the box. Okay? Now the image will look faint. You will not see it clearly. Okay? That's the blurred part we are talking about. So let's go here and we see. We are saying what determines the size of image formed in a pinhole camera? Distance of an object from the pinhole camera. And I told you when you are nearer, the image is clear. Okay? Sorry. The image is bigger when you are near. It is smaller when you are far. Okay? When you are near the pinhole camera, okay, very near, you are going to see an image which is a bit bigger. When you go far, the image becomes, you remember when I asked you, somebody who is far, somebody who is nearer. You remember that? Okay. Look at this. What determines the sharpness? When they talk about sharpness, for us, let's use the word. What will determine whether the image will be clear? You know, an image which is clear, something you can properly see. Okay? You can see it that, yes, that is the jerry can. Yes, that is the bottle. Yes, this is the picture of so and so. That is something clear because you're able to identify, right? But something which is not clear is blurred. B-L-U-R-R-E-D. So sharpness means it is clear or not clear. So when they talk about it determines, it means it is of two sides. Okay? What determines the sharpness? Whether it is to be clear or not clear. Okay? That one I said the size of the pinhole. If the pinhole is smaller as at that size of the pin, the image will be clear. But if you make it bigger, the image will not be clear. It will be blurred. It will be faint. You will not see clearly. Okay? That is what we are trying to mean there. Let's go back a bit. We are saying, yes. Let's go back there. Let's go back there. Sorry. Let's go there and see. Let's bypass this because we have already seen this. Okay. Let's go to the next part. Yes, that one we have finished. The principle we finished. Let's go here. Okay, it is this one. I said the size of the pinhole. I've already explained. If the pinhole is the exact size as the pin is, the image will be what? Sharp, or it will be clear. Yes, if the pinhole is not that size of the pin, it's bigger than that, a lot of light will enter, the image will not be clear. Yeah, there was a time I told you inside the box must be painted what? Black. This is the reason, to prevent internal reflection of light. If light keeps reflecting, the image may not be formed. You may not see anything. So we paint it black inside to prevent that reflection from occurring inside there. Okay? So that you can easily see what's there. Now from that point, I want somebody to go and view that image using our pinhole camera, and it tells us what exactly is going to see through that pinhole. So let's all go there. All right, let's briefly check that. I want that gentleman to look at that candle, burning candle, that light. I want him to look through that camera of ours. I've made it out of a tube, okay? Something cylindrical. Okay, please help us. Look through. Look at that light, please. And whatever you see there, tell us how it appears, whatever, move at different distances. Tell us everything you are going to see there. We are going to listen to you. Yes.
Well, for now, I can see a burning candle, but it's upside down. So appearing upside down. When I move closer, I can see it clearly, but still upside down, meaning that it's inverted. And also the light it is producing is smaller than the real light from the candle. That is the second issue I'm seeing here.
Yes, please.
So I can listening. I can see the candle. It is burning and it's upside down. Then its size is smaller. According to this image I'm seeing, the image appears to be smaller than the real candle. Now, when I move this camera away from the burning candle, I cannot see the candle clearly. In other words, I only see the candle which is blurred. And that is all I can see through this camera right now.
Thank you, gentlemen. Thank you. I appreciate that. Thank you. So, children, you can clearly hear that. So that's exactly what we talked about, the characteristics of images formed on a pinhole. camera. So therefore, we are going to stop at that point. Please remember to do the exercise that we shall give you on that particular work. Thank you. Stay well at home.